Anis? Right. Hi, you all. Wow, so many students signed in YouTube. All right, thank you very much. Okay, I'm with Anis. Anis, how are you, Anis? Please unmute your voice. Okay, you are with me now, all right, on the air. Okay, thank you very much. You can scan your QR code, all right. At the same time, I send to your Telegram, all right. Send now. All right. Okay, I send you now. Okay, do you hear me? I hope somebody can give it back. Are you okay? Do you hear me? Right. Okay, I try to make my voice louder. All right. So I think this is too much louder. All right. Do you hear me? Okay. Yes. Very good. Okay, Anis. Anis. Okay, if you can mute your voice. Okay, unmute your voice is very good. Okay, so now please scan your QR code. Okay, and then and then I want to share with you. Now I'm sharing. Stop sharing. All right, I want to share with you um, the course. Okay, at the e-learning. I'm already send you a link for chapter 5, and then I'm also upload the PDF file for this note. Okay, today we are going to learn what is the numerical differentiation, which is very very important to learn chapter 8 and chapter 9 on the ODE, ordinary differential equation, and partial differential equation. So this is a basic, how we discretize, the ordinary differential equation and partial differential equation. So chapter 5 is a very, very important because this is a basic how you discretize the ODE or PDE using finite different method. The basic of the finite different methods is a Taylor series. So in this case, there is a book, all right? There is no book here. Okay, wait for a while. I left a book in my room. Okay, wait. All right. Okay, there is a book. Okay. You can go to chapter 5. This is very, very interesting topic, and this is a very, very important in numerical when you want to solve a problem in numerical. So you need to know what is a finite different method. All right, chapter 5. Numerical differentiation. Numerical differentiation. All right, very important. You can go to the e-learning. Okay, you can upload. This is an e-learning. All right. So the first that we want to learn is how you do the first derivative or second derivative of the finite different method. All right. So how you can apply Taylor series in this case. how you can apply the Taylor series in this case. And then second, we are using numerical differentiation to obtain a few formula for second order derivative and first order derivative. The important is a centered different formula, forward different formula, backward different formula of the numerical differentiation. Not the backward and forward that we learned before. No, this is on the finite different method or numerical differentiation. And then we give you some example how to apply the formula. All right. So the existing of the formula is come from the higher order Taylor series. All right. The higher differentiation is come from the higher order Taylor series. So that is the basic. All right. So now let's put here my directory. Come on, I want to put my directory here. Bring the directory here. All right. So now I go to the chapter numerical differentiation. All right. So make it bigger. All right. So I want to share screen with you. All right. Oh, Nur Shakila also here. Okay, welcome Nur Shakila to the group. All right. So I'm together with Mas Anis and Nur Shakila. So if you want to have any question or if I want to ask a question, you are in the group. Very easy. Okay. Then this is a very simple topic. Don't worry. Okay. I share screen with you now. Okay. I want to go to my video. All right. Now I'm sharing. Make it more bigger. Okay. I'm sharing the numerical differentiation. Okay. You can refer to the book. Okay. To the book. All right. So let's restart. All right. So now we learn numerical differentiation in chapter 5. All right, where the basic of the numerical differentiation is a finite different method. It's come from the Taylor series. So the question in your mind now is how to discretize dy of first derivative y respect to x or second order derivative y respect to x. Okay, dy over dx or d squared y over dx squared. Right. We want to use Taylor series. Please remember, what is a Taylor series? Actually, we learned, okay, before. However, the way I'm writing is a different. All right. So come on, we left. All right. Nur Shakila and Mas Anis, we want to focus to our lecture today on the numerical differentiation. All right. So now, okay. Let's explain to you the Taylor series after this. Okay, we want to find the gradient at the one point y when x okay equal to x and y is equal to fx. So we want to find the gradient kecurunan pada titik x fx. All right. So what should we do? All right. In this case, we apply the dy over dx is come from the first order differentiation. We create using the numerical method based on the Taylor series. All right. Or the process we can assume as a finite different method. And then the way we discretize, we call as a discretization. All right. So now, there are so many formula, okay, in your book. We go to your book, right? There are so many formula, all right? So now go to the chapters or go to the e-learning or go to the e-book or you go to your book, okay? There are so many alternatives here, all right? So now, when you go to your book, okay, there is a first and second derivative. First and second derivative. For the first derivative, how many formula we have? We have, go to the books, okay? The Taylor series is 5.1, 5.2, 5.3, 5.4. That is a Taylor series, right? And then we want to show the formula of the 2-point forward different formula, okay, 5.5 and 5 point forward, yeah, forward 5.5, 5.6 is a backward 2-point different formula for dy over dx or f prime x. And then you go to 5.8 is a center different formula. This is very important. Center. We want to use center different formula in this note because it's very important. They are covered. Okay, they are grid at I minus 1 and I plus 1. X plus h or x minus h. Right? So they cover 3 points. Alright, and then we go to the second derivative. In this case, we are using Taylor series. So how many points they introduce here is a 5.11. It's a 3-point center different formula for the second order derivative. And 5.12 is a 5-point, okay, second order derivative and some example. Alright, so this is very easy topic. What you want to learn? The first derivative, dy over dx, we can solve in 3 ways: center, backward, forward. And then second order derivative, you can use 3-point derivative or 5-point derivative. The formula is not given because you just refer to the books, and then the important is a center different formula and 3-point second order derivative. All right, 3-point second order. Second order is a d squared y over dx squared. All right. So now I want to focus the notes now. All right. So now let's proof this center different formula based on the Taylor series. We know that using center different formula is a yx plus h minus y x minus h divided by 2h, or sometimes we call fx plus h minus fx minus h divided by 2h. All right. What is h? H is a delta x. You learn already. Okay. It's a size of interval. What is f? A function when x equal to x plus h, for example. All right. What is dy over dx? First order derivative, f respect to x. So now, how we want to prove this formula using Taylor series? In this case, you need to know Taylor series 5.1. Okay, so I write again. The Taylor series 5.1 is a fx plus h equal to fx plus h f prime x plus h squared 2 factorial f prime prime x plus h power 3 divided by 3 factorial f prime prime x plus you can continue as a h power 4 divided by 4 factorial f 5 prime 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 prime. Okay, 4 times you need to do the derivative. Okay, for order. Okay, the fourth order of the derivative, and then you can get this is a Taylor series for the fx plus h stated in 5.1. Okay, 5.1. So then next time if I said that what is the first derivative? Okay, what is the Taylor series for fx plus h? So you can refer to 5.1. All right. So now we continue. We continue to, all right, when we make it more bigger, we continue to fx minus h. So every, okay, h we minus h, all right, replace h to minus h. So what you get? You will get fx minus hf prime x plus h, because h is a negative, squared is always positive, h squared divided by 2 factorial f prime prime x minus h power 3, minus because the odd value, h power 3 divided by 3 factorial f prime 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 x plus h power 4 divided by 4 factorial f prime 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 x. Okay, is a Taylor series 5.2. All right. So when we minus 5.1 and 5.2, what you get? You get the center different formula above. So let's we minus 5.1 and 5.2. All right. When we minus, so the fx minus fx 0, h power 2 factorial minus h power 2 factorial for 5.2 is 0. All right. So there only exists the odd number. Okay, the odd number. So the approximation solution, if you minus, okay, 5.1 minus 5.2, all right, you will get okay, minus, minus, you will get, all right, 2h f prime x. Am I right? Am I right? 2h, you go minus here, okay, all the even number 0, odd number existing, 2h f prime x and plus, okay, 2h power 3 divided by 3 factorial f prime 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 x. So I just ignore the higher order of the Taylor series. I put as a 0. Okay, I put as an error OH power 3. Right, I put as a error. I put as a 0. Actually, it's not 0. I put 0 because I want to make it more simple for the first order for Taylor series to represent second derivative for dy over dx. So you will get fx plus x minus fx minus h divided, okay, or divided by 2h is equal to 2h f prime x. If you want to put divided, if you not put divided, means that you can just get fx plus h minus fx minus h equal to 2h f prime x on your right hand side. So you will get f prime x equal to fx plus x plus h minus x minus h divided by 2h. So please remember, this is a formula we call as a center different formula for first order derivative. It's come from the Taylor series 5.1 minus 5.2. All right, very, very easy. So if I want to ask you to write the formula for Taylor series, and then all right, okay, because there are three formula, is a center different formula, backward and forward. So if I ask you to use the Taylor series 5.1, 5.2 to find the forward or backward different formula, I hope you can do it. All right. So now let's continue. How I prove, okay, how I prove the formula for f prime x, but the different formula we call as a forward different formula, dy over dx equal to fx plus h minus fx divided by h. This is only a point, x plus h in front, fx is a center. All right, so you just use 2 points in front, fx plus h, and center. All right, and then the fx. All right, so the x plus h2 is a, you see the graph. Okay, I come back again. Okay, I many times, okay, write for you a graph. It's very important, the graph here. Okay, we want to find f prime x is somewhere here, but you want to use 2 points, x plus h, okay, forward, and then the value of x. So the point is your forward, okay, we call this one is a forward different formula. If you want to calculate all the point x minus x and x plus h, we call this one as a center different formula. All right. So center different formula is how to create by subtraction between Taylor series 5.1 and 5.2. All right. So now I answer this question. What is the question? Okay, the question is, can you prove, all right? Can you prove, okay, f prime x equal to df over dx, okay, not dy, dx equal to fx plus h minus fx divided by h. We call this one as a forward different formula using Taylor series. So in this case, don't worry, you just minus, okay, Taylor series from 5.1 and fx. All right, so go to your books, okay, go to the books, okay, go to the equation 5.1 and then minus fx divided by h. That's all. Okay, you replace x plus h as a 5.1 is what? Fx plus h, f prime x plus h squared divided by 2 factorial, f prime prime x, okay, plus h power 3 divided by 3 factorial, f prime 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 x. All right, so we want to replace this, okay, to find another method to discretize the f prime x using finite different method based on forward different formula. All right, So don't worry, because we just follow the Taylor series. Okay, come on, we go to the Taylor series. The answer is yes, you can discretize. df over dx is equal to, okay, fx, where is a 5.1? Okay, you know the formula of 5.1 minus fx divided by h. Come on. All right, so from 5.1 minus fx, there is a expression fx. Fx minus fx is 0. All right, and then the existing now is a the after the substitution, we can get the h f prime x plus h power 2 f prime prime x plus h power 3 divided by 3 factorial f prime 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 x and so on. So we put as a oh power 3, we put as a 0. We put this one is error, we just want the first term, okay, the first term. All right, so you will get hf prime x plus OH power 2, all right, and OH power 3, OH power 4. So we make it simple in the numerical. The way we do is a OH power 3, power 2. So meaning that the process of the Taylor series, we do a transcation error at OH power 2, at the second order of the Taylor series, all right. So from 5.1 minus fx divided by h, you will get f prime x. All right. So this is confirmed that the first derivative fx is a fx plus h minus fx divided by h, which is we considered as a forward different formula. This formula is a equation 5.5 in the book. Okay. So I already explained to you the formula for center different formula, and 5.5 is a forward different formula, all right, using the Taylor series 5.1. All right, so the same thing, I'm going to use Taylor series 5.1 to prove the backward different formula. Okay, what is a backward? So this one you need to know. All right, let's we go to the graph again. Backward tu satu tapak ke belakang. Okay, it's one step backward. Okay, we just focus fx. Okay, and then fx minus h. So forward is a between fx and fx plus h, but backward is a between fx and fx minus h. Right. So in this case, we still apply Taylor series 5.1. Okay. What is the Taylor series 5.1? fx plus h. All right. So come on. Okay, understood? Yeah. Okay, we have three formula: forward, backward, center. I'm already prove to you center and forward. Now I want to prove the forward. All right, the backward. All right. So now, never mind. I want to stop here. I want to ask. No Shakila or Mas Anis. Okay, Mas Anis, no Shakila. Please unmute your voice. All right. No Shakila. And Anis. I want to know why we learn. So the question here is why we learn. Okay, chapter 5. Okay, which is chapter 5 is what? Numerical differentiation. All right, why we need to learn numerical differentiation? So this is our question here. All right, come on, if Anis or Mas Anis or No Shakila can answer me why we learn chapter 5 numerical differentiation. Come on. If there is somebody here, all right, Nurul Ain here, Nur Nabila, okay, Lo, Sabrina, Aisha, Nur Alia, okay, all Azizah. Can you answer? Can you check? Okay, can you write the answer for me? All right, why we learn the numerical differentiation? Why we need to find a gradient for the point xfx using 3 point, using 2 point x minus h and x plus h, or forward x and x plus h, or backward x minus h. Why we learn? numerical differentiation. Can you answer my question? Somebody can write, okay, or no, Shakila and Mas Ani can answer me. Can you answer? So Mas Anis, why we learn chapter 5? Mas Anis cannot talk. Okay, never mind. She want to talk, but okay, we can't hear. You can write here. You can write, okay, the question. Okay, why we learn forward and backward. All right. So now let's we continue again. Okay, what is my intention here is that you can answer through the chat. Okay, the next is how we want to prove the backward. Just now is a centered. Now is a how to prove backward different formula. The formula is a fx minus h divided by h. All right, so we call this one is a backward different formula for first derivative df over dx. All right, again we use a Taylor series 5.1. Okay, now let's we replace. Okay, in 5.2 you can see, okay, fx minus h. Okay, in the Taylor series you can get fx minus h f prime x plus h squared f prime x divided by 2 factorial plus h power 3 divided by 3 factorial f prime prime x plus h power 4 divided by 4 factorial f prime 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 prime. Okay, higher order of f up to the fourth order. All right, so this one is for minus. Okay, for minus fx minus h. All right, so the Taylor series, every h you put minus h, so the odd value will be negative. All right, so when you minus fx minus, okay, on your right hand side is a fx minus h, you can get only h f prime x minus oh squared divided by h. So it's a f prime x. Okay, it's a prime x. Come on. Okay, so this is the way. How to do that? Fx minus fx minus h. Okay, but we apply the Taylor series. So the answer is f prime x, okay, is equal to what? Fx minus fx minus h divided by h. All right, so the answer is f prime x. So now, my question, can you derive 3-point backward different formula? You can go to page 120, and then this formula is a 5.9. Okay, come on, we go to the formula 5.9. Okay, I just want to express here. Can you, okay, express formula 5.9 is a 3-point backward different formula using fx, okay, using fx minus h and fx minus 2h. Okay, so I hope you can, the books is already written there. Okay, I hope you can prove using the Taylor series 5.1 and 5.4. 5.1 and 0.4 you minus, you will get the formula of the 3-point backward different formula. All right, so I hope you can derive this one. All right, and then the important that I want to express here, sometimes you need to use a second order derivative. Sometimes you need to use a second order derivative. For example, del squared f over del x squared. All right, why? Because if you want to find the optimum of the parabolic equation, you can optimum value, you can use a second order derivative. If you want to find minimum of the point, you can also use second order derivative. So many functions. Why we need the second order derivative? All right. So the simplest is Taylor series can prove. Okay, the second order derivative is 1 over h fx plus h minus 2fx plus fx minus h. All right. So now let's reprove using the Taylor series. So when we want to discretize, okay, the Taylor series, okay, we want to prove the Taylor series. All right. So you just replace x plus h is 5.1 minus 2fx plus fx minus h is 5.2. So to develop second order derivative, you just use Taylor series 5.1 and 5.2. All right, so you will get this one. All right, so where is x plus h is a forward point. Where is x minus h is a backward. Okay, it's a backward point. All right, and then sometimes it's very tired. All right, if I want to repeat as x plus h, okay, x minus h, all right. So in this case, I'm using what? I'm using I. You already know in chapter 1, chapter 2, I'm always represent the point to I. So I can write f prime prime I is equal to 1 over h. H, you have to know the size of interval. Fi plus 1 minus 2 Fi plus Fi minus 1. So this is the way how I transform. All right. So for the second order, for the center different formula, backward different formula, forward different formula for first order derivative, you can also write like this. Okay. F prime I is equal to Fi plus 1 minus Fi minus 1 divided by 2h for center different formula. All right. Okay, so you can write all the x plus h, you replace I plus 1. All at the point x minus h, you replace I minus 1. All right, why? Because in chapter 8 and chapter 9, you can go to chapter 8, chapter 9, all use IIJJ. All right, we not put in the coordinate form. It's sometimes, okay, not easy to remember. Okay, Pa said that we learn because approximation gradient for any point on curve with initial given small value of h. We are using a finite different method, okay, to find the gradient for the specific point by knowing the initial condition, initial value. Very good. Okay, this answer. We learn numerical differentiation because we want to discretize. We want to find the point for gradient. We want to find the optimum value using second order derivative. So many, okay, we are don't know, okay, if we have a very complex function, okay, second order, third order, we don't want to use calculus. We want to use numerical. All right, so another Azizah said that to differentiate the function, what is complicated to be differentiated? Oh, very good, Azizah. I just finished my words. You continue my words. Thank you very much. Okay, what is that? Because sometimes the function is very complicated. So you use numerical to apply finite different method, numerical differentiation from second order for or a second order derivative or first order derivative with the formula. For the second order derivative, there is another method. Okay, you need to remember. All right. Okay, how to prove the second order derivative based on the 5-point center different formula, 5.12. 5.12. So you can prove, okay, 5.12 is a what? What is that? It's a 5 point, okay, 5 point second order derivative, 5.2 using the Taylor series. So just fit in and then minus, and then you can get the formula for the 5-point center different formula. All right. So for higher order, okay, for higher order in this case, okay, you need to apply for fx plus 2h, fx plus 3h, fx plus 4h. Means that every h you replace with a value. All right. Okay. Okay. Marie not much if informed in the loop. Yes. Okay. Since loop 2, if you solve using the ODE or PDE in chapter 8 and chapter 9, so we reduce the loop by optimizing the second order or first order involving many points. For example, 5-point second order derivative, 5.12 is much more accurate compared to the 3-point second order derivative. All right. So many points, very good. All right. To reduce the loop. All right, very good. Okay, this one is over the over the what we learned. Okay, thank you very much. The important is we want to learn chapter 8 and chapter 9, which is one question in chapter 8, one question in chapter 9. All right, very important. It's very important. All right, so now I want to share with you the example when we are using the finite different method. All right. So if I can share, I'm stop sharing. Okay, I'm stop sharing. I want to share with you. Okay, I have a 3 student here joining me. All right. So I want to go to my YouTube. All right. Okay, I go to this one. Okay. Wrong. Okay, wrong choose file. Sorry. Okay, I go to another one. I think this one. All right. All right. So I want to share with you now. Okay, I stop sharing. I'm already sharing. Okay, I'm sharing here. So let's we go to these notes. Okay. All right. So now, all right, I want to refer the books that you have. All right. Sometimes we forgot the books, but today I want to refer the books. Okay, that you have now. All right. So let's we go to chapter 5. Okay, let's we go to chapter 5. All right. So go to chapter 5, 5.1, 5.2, 5.3, and 5.4 to prove the first order derivative and second order derivative using the uh, forward, backward, and center different formula. All right. So we use this formula 5.1, 5.2, 5.3, and 5.4 used to prove the center different formula. Okay, center different formula, just focus 5.1 and 5.2. All right. For the third order, 3 point for the first order derivative, okay, we need to use 5.1, 5.2, and 5 point, if you want to go for the 3 point, 5.1, 3 point, where is the 3 point? 5.1 and 5.2 and 5.4, right? So this is you need to know, okay? The first is a forward different formula, and then this one is a, let's we go, okay, f prime equal to fx plus h minus fx is a forward different formula, and then this one you can use backward different formula, just f prime x minus fx minus fx minus h, okay, divided by h is a backward different formula, plus oh power 2, all right? So I love if I can write in the discussion f prime I equal to f I plus 1 minus fi divided by h for forward different formula. For backward, first order derivative is a fi minus fi minus 1 divided by h. Right. So this is just to make simple. Okay, simple. All right. So now if you go to 5.7, okay, how the books show you 2 point. Okay, 2 point backward different formula. 2 point backward different formula. All right. Only 2 point backward different formula, so it's not difficult. Okay, you use fx minus fs minus h divided by h. Okay, you only refer to 5.2. Okay, the formula from 5.2. Okay, for center different formula, I also can discretize using fi plus 1 minus fi minus 1 divided by h. Okay, this is the simplest way. Okay, the way I'm writing in the coordinate to the grid form. All right, so okay, and then now I want to continue. If I can show to you the second order derivative, the important is a 3 point center different formula. Is what is a fi prime prime equal to 1 over h squared fi plus 1 minus 2 fi plus fi minus 1. So I just write x minus h to the I minus 1. Okay? So this is the 5.11. What we call this one, 3-point center difference formula. Okay? You are using two types of Taylor series, fx minus h and fx plus h. Right? So this is not given in the formula. You need to remember. Okay, the important is a 3-point center difference formula for the second derivative, f prime prime. Okay? We can also use 5-point center difference formula. Wow, it depends on the 5.3 and 5.1. 5.1. So apply all the formula, you can get f prime prime, the second order derivative is what? Fi plus 1. This one is a 3-point, very simple, kan? Very simple. Fi plus 1 minus 2fi plus fi plus 1. Very simple. Now, let's we go to the example. Before we go to the example, all right, I want to ask somebody here, whether Nur, Shakila, or Mas Anis, or other people, how many formula? How many formula of numerical differentiation you learn? Okay, you learn. Okay, how many formula differentiation that you learn now? Okay, how many formula that you learn now? Can you count? Can you count for me? Okay, how many? Please, okay, stated how many? Put a number. 3. All right. How many numerical differentiation formula that you learn, okay, until now, right? So the first is what? The first is, first order derivative. How many formula? Okay, maybe I can ask you the important center, okay, backward, forward, right? And then you also have 3-point backward formula. So you have 4 formula for the first order derivative. All right, for the second order derivative, you have another 2, okay, 3-point and 5-point. So how many? Is a 6 formula that you learn now. All right, higher order, okay, higher order, the third order, you can use a fourth order, okay, you can use center, backward. This one is we give you, okay, we don't ask you to prove because it's many points involved. All right. So how many now? It's a 6-point. It's a 6-point. So this is the answer. All right. So now let's we go to the, okay, Anis and Mas, we go to the notes, okay. Okay, we go to the YouTube, all right. So we want to find what is the first order derivative for x equal to 2.0. 2.0 at the center. This one is xi. xi plus 1 is 2.1. xi minus 1 is 1.9. Right? So to get a first order derivative, you can apply how many formula? Center, backward, or forward, or 3-point. Okay, 3 points first order derivative based on backward different formula. You can use 4, all right, because 2.0 at the center in the table. All right, so let's we go to the first example, f prime x plus h minus x. So where is 2.0? That one you put I, forward you put I plus 1, backward you put I minus 1. All right, so to get fx plus 1 is a 17.1489, right? Okay, so you need to use formula fi plus 1 minus fi divided by h. All right, this is a forward different formula. So please insert the value. The value is what? 17.1489 minus 14.7781 divided by h. H is a uniform, 0.1. H is a 0.1. All right. So we write the answer here so you can get the value. The gradient for x equal to 2.0 is equal to, so you put all the value here, the value of y, okay, value of y is divided by 0.1, you can get the answer. Come on, press your calculator, okay, fx plus 1 is f 2.1, okay, press your calculator, okay, how much you get, okay, come on, press your calculator. Okay, you will get, okay, this one is a center kan? Okay, come on. Yang tadi tu, come on. Back again, back again. This one is a forward. Alright, so what is the value? So this is the question. Alright, so you can answer the question. Alright, you minus divided by h. Okay, find the value. I stop here, divided by h 0.1. So, come on, find the answer. The answer is, come on. Okay, press your calculator. Okay, 23.7080. Okay, 23.7080. We can also find another value, okay, using center different formula, because 2.0 at the center, you can find the value I plus 1 and I minus 1. All right, so we just done forward, okay, different formula. Okay, backward different formula, and now center different formula. So for the backward different formula, you have xi, I is a 2.0, I minus 1 backward is a 1.9, all right, 1.9. So for this value, come on, we want to insert this value. Okay, we know what is the f prime x plus h minus fi minus 1 divided by h. Okay, before we get the center, okay, we get the backward. The backward is a 20.7490, right? For the forward, I plus 1 is a 17.1487. I minus 1, one step at the back, is a 12.7032 divided by 0.1. So the answer is, press your calculator, is a 22.2285. So you can see that all the value forward, backward, and center, the value is not similar, which is more good. Okay, so I believe center different formula cover up the point at the back, at the center, and the forward. So center different formula much more accurate compared to forward and backward, because forward is one point forward, backward is just a difference between one back, okay, at the backward point. All right, so that is a difference. Come on. And then we can also apply the first order derivative using the 3-point formula. All right, 3-point formula. But we don't want to focus this one unless you are given the formula. At this time, you just insert the value. Okay, now, when we go the second order derivative, okay, come on. Before we start second order derivative, I want to ask, okay, Shakila and Anis, why we need to find second order derivative? Because we want to find why we need f prime prime. Why we need f prime prime? Why? Okay, why we need second order derivative? This question. Because second order derivative will help us whether the point is a maximum or minimum. All right. So that's why we need to learn second order derivative. Okay, Anis, no. All right. So let's continue to the okay, to the why we learn first second order derivative. Go to the page, okay, 122. I'm using 3-point center, different from 3-point second order derivative, and how many points this one? 1, 2, 3, 4, 5. 5-point derivative for the second order derivative. I just put, where is I? I is a 2.0. 2.0. So I plus 1 is a 2.1. I plus 2 is a 2.2. I minus, okay, I minus h is a 1.9. I minus 2h, okay, I minus 2 is a 1.8. So in this case, you need to remember all the points. So if I want to apply the second order derivative, 3-point fi plus 1 minus 2 fi plus fi minus 1 divided by h is a what? is a second order derivative, 3 point. Okay, TS is a 3-point derivative. So I just put f prime prime 2 is a fi plus 1 is a forward. It's a 17.1489 minus 2 fi. Fi is a what the point we want, 14.7781 plus I minus 1 at the back. Go to the back. We will get plus 12.7082 divided by h squared. H is a 0.1, but you squared, you can get 0.001. All right. So the answer is, okay, press your calculator, second order derivative is a 29.5900. Is a positive value. If positive, means that the graph is a maximum. Okay, the graph is a maximum. You can see here, there is a maximum point because the graph is increasing. If you draw the graph, there is increasing. So there is a positive value increasing, right? You can apply to 5 point by fx plus 2h is a forward, 2 step forward, 19.8550. And then f minus 2h is a backward, all right? And the backward, all right? So you can find the backward here is a 10.8891 is a x minus 2h, right? So it is very easy actually. Okay, we just put in what happened in the table, what the value in the table, you just fit into the formula. So how many formula now you learn? Okay, you learn 6 formula, but just now I'm writing you the 5-point second order derivatives. Okay, the formula 7. And then I'm also using the first order derivative based on 1, 2, 3, 4, 4 points. So 8 formula. Now you learn about the differentiation. I don't want to go to the higher point. I just want to know only 2-point and 3-point derivative for the first order and second order. That's all. Very simple. All right. So there's a question here. Does it mean center difference is better because absolute error is small? In this case, because center difference formula is very broad. It's 1 point on your right and 1 point on your left. So you covered 3 points. Forward difference formula, just 1 point to your right, okay, forward. And if you're using backward center formula, it's just 2 points. 1 point on the back and the point for xi. All right, so center is better because they're covered. 9 points is very good. This now 5 point is much good because they're using higher order of the Taylor series. All right. To find the maximum or minimum, yes, we use a second order derivative to find maximum or minimum. Very good. All right, I don't want to spend so much time. So you can go to the YouTube. I sent already to the e-learning. Okay, I stop sharing. All right, I'm stop sharing. I go to my e-learning. Don't forget everything in the e-learning. I send to you the, you can go here. I send to you the link. All right, and also the live YouTube. Okay, now this also can support you the class. All right, don't miss out your class. All right, so okay, since you are already have the attendance, okay, where is your attendance? Okay, I'm stop sharing. We go to your attendance. Where is your attendance? All right, so okay, this is your attendance. So to make sure that, okay, 49 now over 48. To make sure that 49 student, okay, it should be 48. Where is the rest? I'm looking for the rest using my online attendance. I can show you who are absent today. I give you a simple quiz. All right, you go to the chapter 4. Can you go to chapter 4? I'm stop sharing. All right. Can you go to chapter 4? I just want to play a simple quiz to you. Don't stressful. It's just want to make sure that my student, okay, following me, they are using a student-centered learning. They are learn themselves. All right, they can follow my class. My class is not difficult. It's very simple. I try to make sure that the class is simplest as I can. All right, because to make sure that you can answer all my question. All right. So now I share with you. Okay, something very interesting here. All right. Okay, please prepare your what your okay, start, please prepare your calculator. This time, please prepare your calculator. Please prepare your book. All right. Why? Because you need to have a calculator. All right. You need to count. You need to count. Okay. Linear least square method. You need to know what is a summation xi, summation siyi, summation si squared using the calculator. Prepare your calculator. Don't pick up all the answers here, okay, but you need to calculate. All right, you need to calculate. I don't want you to pick up and then okay, the time is very short. Okay, the time is very short. All right, so we stop here. Okay, we go to the classic here, continue. All right, I hope that you can share with you. Go to the code here. Okay, you can go to the code here. All right, so I can also write at your Telegram. Don't worry. Okay, I send to your Telegram, and then I'm also can write the QR code. Okay, the code for answering the question. Come on, you go to the Telegram. Oh, okay, you can click. All right, you can click. Sorry, yeah. Or you can click through the. I send to your. I'm also sent to your. All right, here. Get your live YouTube. All right, very fast, people. All right, come on. Okay, I go to the this one also. Okay, join this here. All right. You are given 5 minutes only. Okay, prepare your calculator. Okay, because the question is how to find a summation x, summation xi, summation yi. You need to find, because the second question they ask you to find summation xi, yi, and then find the error. All right, find the error. What is error? Error is different between the data and the linearly square method. All right. So now 28. I hope there are somebody, many come in to join the quizzes. The question at your handphone. Don't worry. Okay, this is not based on the monitor. All right. So come on, Anis, and come on, Shahira just now. All right. Come on, we go to the quizzes. All right. Okay, I want many people, okay, many students join me, 31. I'm waiting all of you. Okay, make sure that you are join me, all right, and then please put your name, okay, the full name. Make sure Ain, come on, you can write the good the complete name, because I want to take the attendance. Okay, A19 also. Okay, come on. Write your complete name, because I want to take attendance to qualify your attendance today. All right, and then come on, go to your chapter 4, follow the chapter 4. You can refer to chapter 4. However, the question is very short time. You need to answer in 5 minutes. All right, come on, somebody, no one to, okay, come on, declare your attendance by pick up your answer here. All right, Fatona, Rabiatul, all here. Aziza, Hani, okay, Nabila, Shahira, come on, very good. Hushan here. And then some more A19. Okay, please declare your name after this, because I don't know who is A19. Lee, JY, I know who you are. Nadira, very good. Loy, Bayan, you are here. This one you are here. Akila, also here. All right, so I'm waiting others. There are 46 attendance for today. Come on, others. Okay, very simple question. Okay, two question. Question 1 is related to question 2. All right, question 1 is related to the question 2. All right, so press your calculator very fast to get summation xi, summation si, summation si squared y, summation xi squared, summation siyi, and so on. All right, so why we need to have these games? Because you need to make sure that, okay, we want to make I want to know that you are in the class, or you are doing revision, or you do some self-centered learning. All right. So come on, somebody can go in. Okay, even though we start the quizzes. All right. Okay, come on. Yeah, your connection slow. I know what to do. All right, because that's why I'm using YouTube. It's very easy for you to join. However, when I go any apps, it's not easy. All right, never mind. Okay, I'm waiting others. Okay, we can go in. Okay, you can start. All right. So may I start? All right, I'm asking from the rest. May I start the quiz? May I start? Okay. Okay, I know all of you are waiting, or you need to do some fast revision to answer this question. It's depend on you, all right? It's depend on you. So if you want to do revision still, I'm waiting others to join my quiz, all right? You can come later, okay, because the quiz is open, okay, in the duration, okay? All right, I give you time. Let's restart. Can we stop? Can we stop? All right, we can see, okay, student, all right, can do the references, okay, some of them. I'm not sure because I'm too fast, maybe, all right. Maybe the student-centered learning, okay, still not, okay, function very well. Maybe you need a time to understand chapter 4, all right? Because now we go already to chapter 5, all right? So who are still not answering the question, please do so, all right? Please do so, all right? So I'm looking your marks here. Okay, let's end the session and then you can see, right? You can see, let's end the session. All right, you can end. Okay. All right, so who is the winners? Okay, we can go to here. The winners is Kilah. Second is Sabrina. The third is Zahira. All right. So the winners is because of this one is all the 100%. Okay, student, I'm already sent to your telegram. This is 100%. Thank you very much. Okay. The important is you are with me. All right. So how many? This one is your answers now. Okay, you can see here. All right. 100% too many lah. Okay, many is a 19 student. Okay, the rest is 50%, and then others is not answering the question. All right. So never mind. Okay, we try another time. All right. Thank you very much for your cooperation. I hope we can what we can do a student-centered learning. I'm only a coach to make sure that you're following me. Okay, post my link to the YouTube, to the live YouTube, okay, to the e-learning to make sure that I support you. My e-notes, okay, my e-notes also presenting to you to make sure that you can compare the notes that we're giving in the e-learning, the e-books, okay, and then the books that you buy from GMCP is really help you. Okay, Mom? It's really help you. All right. Thank you very much. Okay. Bye-bye. See you next time.